All right. This is a question that was asked by one of our students. Can we do this? Yes, we can. So it's 24/12, day 6, chapter 2, section 3, properties of functions. So we have from chapter 2, section 1, number 18. The function is f of x equals square root of x minus 11.
I actually got the answer right, but I too had trouble because in maybe in algebra, I don't remember having, or maybe it was in trigonometry, I don't remember having to rationalize the numerator. Always,
Yeah, it was always a denominator.
Well, see, and that's wrong with the teacher. It depends on what you're looking for, because in this case, well, see, when we set it up and we get 0/0, rationalizing the bottom ones won't do us anything, because it's already as simple as pretty much as far as it can go. The only thing we can do is rationalize the numerator. So you try to do one or the other, or both if you have to. And that's where in this one we do rationalize the numerator. I see what you're, and again, that's the teacher's fault. Said they shouldn't make these general rules that you won't try anything else. So you just try whatever works. If one doesn't work, here's the bottom line: is in mathematics, if one method doesn't work, try another method. And that's what this one's about. Okay, we have to use what's called the difference quotient, which is f(x plus h) minus f of x over h. And when you get into calculus, this is where it's all going to begin. This is where calculus begins, the difference quotient. So we have f of x. That's the square root of x minus 11. We have this part. We have to figure out this part first before we go any further. So we have to do the f of x plus h. So anywhere C in x, put a plus h behind it. Now we have the numerator complete. Because whatever we have here, in place of x, we put x plus h. And let's plug what we have in here. We have the square root of x plus h minus 11 minus the square root of x minus 11 over h. Because as we see here, as h goes to 0, what do we get? Because remember, what are we looking for? What is the difference quotient all about? We have to understand that first. What is the difference quotient all about?
difference over time.
Yes, it is. It's a slope, but a slope of what? Difference quotient is used. Oops. The difference quotient is used whenever you're trying to find the slope of a curve at a point. Whenever you're trying to find the slope of a curve at a point, basically what you're doing there is you're finding the slope of the line tangent to the curve at that point. So if you have a curve and you want to know what that slope is, we have to find the slope of the line tangent to the curve at that point. And that's what this is all about. Because this formula here finds the slope. It finds the slope of the line tangent to the curve at that point. So when h goes to 0, we have x minus 11 square root minus square root x 0 over 0. Can't do anything. So what we have to do here first because there's nothing we can do on the bottom. So we multiply by the conjugate of the numerator. The conjugate is just change the sign between there. So it used to be minus, now it's plus. And we have to multiply it top and bottom. Why top and bottom? What does this equation equal?
1.
1, but same thing over same thing. So we're multiplying by 1. We're not changing the equation, we're changing the way it looks. So on the bottom, we have on the top, we have to FOIL it out. We multiply this times this, which is the square root of x minus h minus 11 squared, plus square root of x minus 11 times square root of x plus h minus 11. Negative, so minus x minus 11 x plus h minus 11. Negative times positive is negative. Radical x minus 11 squared. That times that squared. That's the hardest part because it's a lot of writing. This is where the mistakes are going to happen. Now, during the simplification process, so what happens here? The square root squared, those cancel. So we have x minus h, or x plus h minus 11. This and this cancel. Minus x minus 11 square root squared, those cancel. So we have x minus 11. X plus h minus 11. Distribute, get rid of the negative, so it's minus 11, or minus x plus 11. Once you get rid of parentheses, combine like terms. So the x's cancel, the 11's cancel. So we just have h on top over that. So we have h square root x plus h minus 11 plus square root of x minus 11. H is canceled.
That would be done enough.
No, 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 no. I don't need the parentheses anymore. Is that the answer? No, because as h goes to 0, we're left with which is there. That is the slope of our line tangent at any point x that you give me. Traditionally, we wouldn't be finished here. Why?
Yeah.
You have radical on the bottom.
Mhm.
So typically what we normally do is multiply top and bottom by the radical.
Actually, for the homework,
It would take this. I know. And
okay.
the reason for that is because it's easier for them to program. On the bottom, this times this is simply x minus 11. But in the common convention of mathematics around the world, that is your answer. Or if you want to, you can leave it here. But the computer will take that. So again, where you stop depending on what the computer will take. I don't know if it will take these other ones, but it'll definitely take that because it's easier for them to program. Just the radical one? Really?
Yeah.
Dang. They're really lazy, aren't they? Good question. Did I answer it? Did I answer it for you?
How did you remember?
Where did you stop?
So I stopped it. I'm gonna tell myself.
Right here?
I was just like, worrying about like 2 more tries. I just didn't control everything. That was something.
Well, rule of thumb, whenever you do the difference quotient, the h on the top, if you have rational, it'll always disappear. It'll if because think about it. If it doesn't disappear and as h goes to 0, then you have a 0 on top, which makes the whole thing 0. So it's typically it should cancel out and you should have a simplified algebraic form. Actually, what we've just done here is we've just taken the first derivative of a function. This is what you're doing in calculus. More questions? Any more questions from the homework? Nope.
Wasn't able to complete question number 9 and 2.3.
Well, we haven't done 2.3 yet.
Yeah. Oh, okay.
That's what we're doing today.
Okay, my bad. Never mind.
Well, let me
I
think.
thought I was right on track. I didn't know.
You're ahead of the track. Ah, crap.
Don't have to do it.
It was 2.1. Yeah, we'll do this. I'll show you how to do this in a second. That's part of the lecture
Okay.
today. Okay. So for today, our exciting lecture is chapter 2, section 3. Functions. The properties. All right, oh, you begin. Don't need that. What is a function? What defines a function? How do we know if something is a function?
On this.
Yeah, it has a one-to-one correspondence, means it passes the vertical line test, which means no two x's can have different y values. What else does it tell us? Odd versus even. What does this mean? Basically, what this means is the function reflective about the y-axis? I mean, yeah, the y-axis or the origin? That's all it's really telling us. A function is even if I change the value of the x from positive x to negative x, it doesn't change the function at all. That's when we know it's off. And I'm going to show you a shortcut so we don't have to go through all the long drawn out steps that they're saying. And then it's odd if I change x to negative x, then it changes the value of the function from positive y to negative y. So this means it's reflexive about the y-axis, about the origin. If you look at an even function, let's say the square root, or the square function. If I put in 2 inside there, I get positive 4. If I put negative 2 in there, I get positive 4. So that's what this is saying. If my negative 2 and my positive 2 gives me the same value of 4. That's an even function. An odd function like a cubic function. If I put positive 2 in there and I cube it, I get 8. If I put negative 2 in there, I get negative 8. So if I put the negative in there, I get the negative answer. If I put the positive in there, I get the positive answer. So that's what it's really telling us. So this is how they want you to test it. Let me look for some examples here. I'm going to show you shortcuts for this. So here's some examples. Example what? No. So tell me if these are odd or even functions or neither. F of x equals x squared minus 5. B g of x equals x cubed minus 1. C h of x is equal 5x cubed minus x. And D f of x equals absolute value of x. Is it odd or even or neither? Okay, everybody write these down. Let me show you how they want you to do it. Then I'll show you how I want you to do it. Mine's gonna take, so you just look at it and you're done. So let's look at the first one. X squared minus 5. Remember, if it's even, this has to be true. So I do it two ways. I plug in 2 and I plug in -2. So f of 2 gives me 2 squared minus 5. 4 minus 5 is -1. And f of -2. -2 squared minus 5. -2 squared is 4. Minus 5 is -1. Do we get the same answer from changing the signs? So what does that tell us?
Even.
It's even. We know evens for sure. Okay, that's it. So once it satisfies that, then it's okay. Let's look at the second one. G of x, x cubed minus 1. Same thing. Let's make x -2 and x +2. G of -2, -2 cubed minus 1. -2 cubed is what? -8. -8 minus 1 is -9. Two cubed minus 1. 2 cubed is 8 minus 1 is 7. Same numbers? Opposites? No, so it's neither. X equals -2, x equals 2. Five times -2 cubed minus -2. -2 cubed is -8. Negative and negative makes it a positive. So -40 plus 2 is -38. Five times 2 cubed minus 2. 2 cubed is 8. 5 times 8 is 40. So I change the signs. I get the same number, but different signs. So it's odd. And that's what odd. If I change the input, sign of the input, I change the sign of the output. But there has to be the same numbers. And the last one. F of x is absolute value of x. X equals -2. X equals 2. Absolute value of -2 is? Absolute value of 2. So what is that?
Yeah.
All right, that's a lot of work. We should have finished those 4 questions in no more than 4 seconds. I'll show you why. We looked at the 4 possibilities. Okay, here are the 4 possibilities. Actually, it's gonna be a little more than that. Here are the possibilities. We learned that this was an even question and this was an odd. Easy to know. If there's nothing else in there, look at the exponents. This is odd, so it's odd. This one's even, so it's even. Duh. So that's a good clue right there. If all of the exponents are odd, then it's odd. If all of the exponents are even, then it's even. So here's an even and an odd. Is that going to work? No, that's a neither. You can't mix them. Like granimals, you can't mix them. This one's odd, this one's odd. So the function is odd. How about a constant? X to the 0, which is an even exponent. So a constant is the same as an even exponent. So this is even, so this is even. Odd and even doesn't work. So all you have to do is look at the exponents. If all of the exponents are odd, I don't care how many you have, if all of them are odd, and so all exponents are odd and no constant number, those are odds. Yes. Yeah. Because for fractions, you have to look at, well, let's look at that next with an example you told me earlier. Let's see how that works. So an even function, all exponents are even, and or there is a constant number. That's all you have to know. So by looking at those, again, I told you it should take you more 4 seconds. How about the first one? Is that odd or even? Even, because that's even, that's a constant. How about this one? That's odd, because that's odd, that one's odd. It's a 1.
Oh,
There's an X. How about this one? Odd and a constant. Can't do it. Now, why is absolute value an even function? Absolute value is the same thing as that. Let's think about what happens in an absolute value. If you put a negative number in there, the negative is stripped out. What does the square do to a negative number? Makes it -3 times -3 is +9. And what does the square root do? Brings it back down to the size of the number. So that's all it does. So that's how come the absolute value is an even function. So absolute value plus a constant, that's going to be an even function. Absolute value and an odd exponent is a neither. Because you can't mix odd and even. Well, that pretty much does most of my lecture.
Wait, you said the constant is the same as even?
The constant and evens go together.
Okay.
If a constant and an even function, they go together.
Okay.
Because it doesn't change anything. All it does is just a vertical shift of it.
Hmm.
Yes.
Oh, I'm sorry. So when do you know when it is a constant? When it's not?
Is there a variable? That's a constant, if it's a number.
Uh-huh. So it's a variable.
Yeah, because if it has if it's a variable, then it has to have a degree. Every variable has to have a degree. This one has a degree 1, everything else. So by looking at that, if it doesn't have, if it's a constant, it doesn't have a degree. Or even if it did have a degree, it doesn't matter. It's still a constant. It's just a bigger one. Okay, that does the whole. Let's look at fractions then. So we know that this is an odd function, and we know that the denominator is an even function. What happens when you put them together?
They're negative.
Well, let's see. Let's plug in 2 and -2 and see what happens. So here we have 2 squared plus 3, -2, -2 squared plus 3. What happened there? So if one of them is odd, the other one is even, we know it's going to be odd. If they're both even. If they're both odd, are we sure? 'Cause remember what happens when you have, this is where the trick comes in. That's an odd function. That's an odd function. So on top, we have -2. -2 cubed is -8 plus since they're both odd, uh, 2 cubed plus 2, 8 plus 2. What does that mean? It's an even function. So if you have 2 odds, then it's an even. If you have 2 evens, it's an even. If you have an odd and an even, because it has to do with changing of the signs. An odd function changes the sign what you put in there. So if the top and bottom both change signs, those signs cancel, which brings you back to the original equation. So with fractions, we have odd over even, odd over odd, even over even, and even over odd. In our examples, what do we have? We had originally odd over even. Odd over even. That one.
Yeah.
And what happened to it?
It turned into odd.
Odd over odd,
That's even.
even over even, even over odd. What do you think is going to happen?
Even.
Let's see.
Um,
I'm thinking it's going to be same as this one. Let's just hold off on that. Because remember what happens when if it's an odd function, it changes sign.
hmm.
So
Doesn't matter where the sign is in the fraction.
it doesn't matter if the sign's on top or bottom, right? It changes the sign of the whole fraction. So there you have it. A good question. But what about this one now? Here's a test of the smart people. How about that one? And why, what's neither do? It changes the sign of the function itself. If it's odd, if the x is odd, I mean, a negative, it's going to be a big negative number minus that. If it's positive, then it's going to be a smaller one. Yeah. So if one of them is neither, then you can't do anything about it.
One is neither, it just cancels.
Right. You cancel the whole thing. And even if it's both neither, it ruins it because the numbers change, not just the signs. Very good questions, actually. Yeah, because this one's and this one's neither. This one's neither. Because that's an odd with a constant. You can't have that's a neither. And that's a neither. So if one of them or both of them are neither, you have neither because it changes the number. And if you change the number, it changes the fraction.
Okay, would it get a negative coefficient in either?
Same thing. It doesn't matter if you have a negative coefficient or not. It's still, if it's an odd function, it's just going to change the sign from negative to positive, positive to negative. If you have neither, it's going to change the value of the answer. It's going to change it no matter what. What we talked about last time, library of functions. What function does this belong to?
X,
X squared. How about this one?
X cubed.
How about this one?
Third.
Remember, if it's square root, it can't have negatives because you have to have two. If it has a positive and negative, it has to be an odd number.
So 1 over X? Or absolute, yeah.
1 over X. So now, odd versus even. Odd or even. Yeah, because that's even. And we know because it only flips across the y-axis. How about this one?
It's odd.
Because it's an odd function, we know it because it flips across the origin. Odd or even? Because it's an odd number, same thing. It flips across the origin. This positive positive is this same negative negative. How about this one? Because it flips across the x-axis. So this value here maps to this one maps to this one. So if it maps across the x-axis, then it's an odd function.
Like reflecting.
Yes, that's exactly what it is. It's reflecting, yeah. So identifying them pretty easy. Okay. So that takes care of that whole first 12,000 pages. Increasing versus decreasing functions versus constant. We know what they are from algebra and everything else, but can we define it? What is how would you define an increasing function?
Goes to infinity, y goes to infinity.
This is accurate, yeah. Because as we go on our graph, as we always go to the left, always x always goes to the left. So we know it's increasing because as x goes to the right, the values of y keep on going to infinity. Right. How about a decreasing? A decreasing function. So same thing there. What do you have to look at there? As x goes to infinity, what happens to y? Y goes to negative infinity, right? Constant function. As x goes to infinity, what happens? Y stays the same. Remember, a constant function looks like what?
So a straight line.
A horizontal, well, all lines.
Oh,
It's a horizontal line. But now, let's look at a more closer. What we're looking at here is from the moon. We're looking at the Earth from the moon. We're seeing is increasing or decreasing. Let's look at it more closer. An increasing function. We have a point x1, y1, x2, y2. If x1 is less than x2 and y1 is less than y2, then the function's increasing.
Oh, I get it now.
Yeah, so if this point is lower than this point, then it's increasing. Because we have to be able to look at smaller subsections of graphs. How would we say decreasing? If x1 is less than x2, here's x1, here's y1, here's x2, and here's y2. Remember, the x always goes to infinity. So in other words, x1 is going to be smaller than x2. Then y1 is larger than y2. That's a decreasing function. If the first point is higher than the second point, then it's decreasing.
I was getting lost in how they were trying to explain it in the book and understand the language.
But now it makes sense, I hope. If it's a constant function, x1, x2, then y1 equals y2. That's a constant function. Even at that, we look at two separate points next to each other, x1 and see where it goes, x2 where it goes. There's like a tangent function it's periodic and it's always increasing. So here's X1, here's X2, here's Y1, here's Y2. It's always going to be increasing. So in the domain, each of your values in the domain of tangent function is always an increasing function.
I don't mean to get off topic, that was just
No. It's just as if it's in your head, spit it out.
something in trig where like the trig function, like when it is to your eye, it looked like it was decreasing, but they called it an increasing. I don't know exactly remember.
Yeah, if you remember that, show me, because I mean, you can see, if it looks like it's going from left to right, if it looks like it's going down, it's
Yeah.
decreasing. Five, six. So we have a dot at -6. So if our graph looked like this, tell me where it's increasing, decreasing, or constant. So where's it increasing?
Increase it at -4, and to 4. Oh, yeah, 0 because of the Y.
Yeah, because from here to here. So what do I put around those? Always put parentheses. Because what exactly is happening at that point there?
Both.
Is it increasing or decreasing? It's doing both. Since you can't distinguish, you have to put a print. You can't say either way. So at every intersecting point, it's always going to be a parenthesis. Where is it decreasing? -6 to -4, parentheses. Then where else? 3 to 6. What do I put between there? The U for union.
I thought all of that too, but when I try to put that in the homework, it wants you to put a bracket.
For that one?
I'm
For the
not
homework?
saying you're wrong.
Oh, no.
It asks for a comma, actually.
Yeah, and a comma, I didn't ask for it, didn't even give you a choice to put in the union.
See, again, because it's much easier for them to program with. No, I believe you. It's the common convention of mathematics says this is how you put it because we don't know what's happening at each of these intersecting points. And it's a union because what this means is it can be here or it can be here if I talk about decreasing. Why? The reason for that is because this is a more complex control function as opposed to just a comma, which is on the keyboard. So yeah, since it does the grading, use that, but know that this is how you're supposed to put the answers. Well, why it uses brackets, I have no idea.
Yeah, that's what, I don't, yeah, good.
So it's constant from 0 to 3. Because at 3, you don't know if it's going constant or if it's decreasing. At 3, 4, you don't know what's doing. So it's both. I've had my issues with it does a lot of good, but this kind of stuff it ruins it for the students. Because if we were using it as pencil paper and you put brackets, it'd be wrong. So yeah, so knowing what the answer should be, knowing what it wants, it's gonna be two different things. do what it wants. It's grading you.
Okay.
But be aware that if you ever do this on pencil and paper, this is how you do it. Let's see. Oh. Local extrema. By local, we also refer it to, we can call it a relative extrema. What that means, it's within a certain domain. Because if it's not a small domain, so if it's over the entire thing, then it's called an absolute extrema. Or global extrema. So a local versus global is a smaller subset of the entire domain. Now, what is an extrema? The highest or lowest point. Instead of highest, we use the term maximum. For lowest, we use
Minimum.
minimum. If you have plural of it, it's maxima and minima. So these are just the plurals and singulars of them. So maximum, the highest you can go is the maximum altitude. The lowest you can go. So the maximum is there. The lowest point, the minimum, is there. For the quadratic formulas, this one would look like negative x squared. This one would be x squared. Is this a local extrema or an absolute global extrema?
Local.
Global, because if this is the maximum, the vertex, there is no other point that's higher than that, because everything else goes down. It goes down forever. So this one is, as an extrema, it's both local and absolute. You can have both. It can be both. So the absolute can also be local because it can be of that small area as well.
So like for local, you could have a maximum, but there could be another point on the function that's actually higher than that, they're excluding it because they're only talking about within that domain.
Right.
I got you.
So looking at these extrema values. This is local, this is local, 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 local. This is also the absolute because it's the highest over everything, but everybody's local because of their small little domains. Yes,
There's also turning points with other turning points.
yes. And yeah, you've seen this stuff before, and these are all called vertices. The reason we're talking about these is what happens at a vertex. One of two things. How do we know it's a vertex? Remember, we just talked about maximum, increasing, decreasing functions. If it's a maximum, so if it's a maximum, what has to be true? Then 1, to the left, it is an increasing function. Because if that's a maximum, it has to climb up to get there. And then to the right, it is a decreasing function. It has to be going down now, so it's decreasing. So if we have a value and we are saying it's a maximum or minima, we look at points to the left, to the right of it. If these 2 points are lower than this one, then that's got to be a max. If these 2 points are above it, then this is a min. And for a minimum, it's just the opposite. Remember, as we go left to right on X, what happens to the left of X for a minimum? Yeah. If a point is a min point, then to the left, it is a decreasing function. To the right, it is an increasing function. Because it has to be going down to get to the minimum, and it has to climb back up. Pretty easy. Okay, here's another question. How do we know if it's a maximum or minimum, besides looking at those? How do we know if it's a maximum or minimum point? We know we have a maxima or minima if the slope is 0 at that point. Okay, so let's now put together stuff that we've been talking about. How would you prove that? If I gave you the function and I said the extrema is at this point, how would you prove it with what we know so far? Yes, you'd have to use a difference quotient because we can't use 2 points. Very good. We use a difference quotient and it would equal what? 0. Because what does a difference quotient do? It finds the slope of the line tangent to the curve at that point. So the slope of the line tangent is slope equals 0. Very good. With what we know so far, the only thing we can refer to is the difference quotient. The difference quotient is x plus h minus f of x over h, as h goes to 0. Very good. See, being able to put together this stuff is a lot more safe than doing it each step as we're just going along. Try to take what we did in the past and relate it to what we're doing now. It all relates. Okay.
What if you have a function and it's high and it has a point on it that's higher than all the other points, but there's nothing happening to the left of it and something happening to the right of it?
Like that. We wouldn't know the slope of that one. You can't define, because you have to have, it has to be the slope tangent to it. Now, the reason for this There's only one tangent. Anything else would give me a secant line. But if that's the point and there's nothing to the left of it, how many tangents can I draw to it? Infinite many, so there is none. So that one doesn't have a can't be a slope of zero vertex because it doesn't have a slope at it. It's just a point. Good question. But however, these we can determine, and they all have slopes of zero. Very good question. Let's look at this question. Finding local maximum is the graph of the function. At what numbers, if any, does a function have a local maxima?
There's, wait, actually,
Where does it have a local maxima?
that one,
At 1, 2. When x equals 1, that's the local maxima. Where's local minima? -1 and 3. Remember, these go on forever, so you can't really say that they're maxima because they never end. It's only physical points you can get to. About this one. What about the absolute? Does it have an absolute extrema? Because it's half right, half wrong. Because remember, what is an extrema? Max or min. So you're right. It can't be the maximum because it goes forever. But how about the lowest? Is there a lowest point of this entire graph? Right there. So there's the absolute minima right there. So that's why you guys are half right, half wrong. And that's how to give you anyway. Does this one have absolute maximum minima? Where? Yeah, here's the absolute what?
that's,
And this one?
that's a,
How many locals do we have?
just two.
2. Because we can't say much about those. But we can. Extrema points, that's another thing we're talking about. The end points. If this point is higher than this one, then it's a if this point is higher than this one, that means this one can't be the minimum. Since this one is lower than this one, it can't be the maximum. So it's nothing. And we can't say whether it's the local maximum of the domain. We just say that that's just a point there, and it's lower than everything else because everything to the right is getting higher.
Mhm.
But for sure, we can say about these. Okay, what else? There's some examples. What's some examples? We just talked about the theorem of it. Ah. Here's an example. Okay, graph this one. F of x equals 2x cubed minus 3x plus 1 for -2 to 2. And approximate if there's any local maxima or minima. Well, let's make it squared instead of cubed because that's gonna make it a little bit more harder, more difficult, because if it's a cubic function, it's gonna look like this. Let's see if this one can work. Can we factor this one out?
Yes, wait, no.
Well, let's see. Okay, since the leading term is not one, we put 2x and 2x. The second sign says that both the signs are the same. They're both minus. And the only way this equals 1, but 2x and 2x is 4x. Let's make this 4x. Because it originally said use a graphing utility calculator, which I hate those. But let's look at this right now. If this was the case, if we had this polynomial, what does this tell us? It's a quadratic equation, so what's the shape of it? It's a U. Does it open up or down? That's positive, so it's up. The y-intercept is 1. Where's our x-intercept? Yeah, since these are both the same, take those, set it equals 0. Since both of these are the same, then we know our graph is going up from there. Because we only have one x-intercept, and that's the vertex. It opens up. So this is our local min and our absolute min. They're both the same. The local min is at 1/2 0. Let's go ahead and look at what the graph would look like if it was, we put it in the cubic in there. Equals 2x minus 3x plus 1. That's what the graph would look like. So do we have any absolute maximum minima? No.
Oh, yeah,
Because it's a cubic function, so we know there's opposite directions. So there's no absolutes. We only have locals. And the local maximum would be here at negative 0.7, and the local minimum would be at positive 0.707. It is a reflection, but it's also shifted up one space, which is that +1. So yeah, so it has no absolutes, and we have those two local minimas, extrema. Finding the equation of a secant line. What does a secant line mean? What is a secant line?
Something that intercepts the, slope?
You can't intercept the slope. Slope is a value.
Oh,
A secant line is any line that bisects a curve. So it's a line that crosses the curve at 2 points. So here's our example. Suppose we have this function. Negative 2x squared plus 4x minus 3. Okay. First, find the average rate of change. Let me see what values I'm looking for. Find the average rate of change from -2 to x.
use formula for that?
Which formula would we use? What does average rate of change mean? What's another name for that in mathematics? Right, slope.
intercept?
It's a slope, not a slope intercept, but slope. The average rate of change is a slope formula. So the slope of G is equal to, it's going from this one to this one. So this is x1 to this is x2. We're going gx minus g of -2 from x minus -2. Because this is our, we're going from this one to this one, so x1, x2. So we have g of x, which is the original function, 2x squared plus 4x minus 3 minus g of -2. So g of -2 is -2 squared, 4 times -2 minus 3. X plus 2. Because here's g of -2, I just plugged it, and that's what that is. Put -2 in there and -2 in there. We have -2x squared plus 4x minus 3. -2 squared is 4. 4 times -2 is -8. 4 times -2 is -8 minus 3. So we have -2x squared plus 4x minus 3. 8, 8, 16, 3 is 19. We have -2x squared plus 4x minus 3. The negative makes it a positive 19. -2x squared plus 4x. 19 minus 3 is 16. they're all even, so I can factor out a -2, which leaves me at x squared minus 2x minus 8.
How do you factor that out again? Cause,
Because they're all even, so I took out a -2, since that's the leading term. Now, that's a good question. How do you factor out? Whenever you factor something out, it's the same. So here I have -2x squared plus 4x plus 6. I want to factor out a -2. So what I do under each one of these terms, I divide by -2. Whatever I factor out, I divide each term by -2. So -2, those cancel, so I have x squared. +4 divided by -2 is -2. +16 divided by -2 is -8.
I think you're just doing a negative to make sure that x is positive.
Yes. So I have, on top, I have -2. And this can factor out even further. The signs are opposites. One's plus, one's negative. The bigger one's negative. What times what is 8 when you subtract them, you get 2? 4 and 2. And the bigger one's negative. So the 4 goes here, the 2 goes there. So the x plus 2's cancel. So I have -2x minus 4. There is my average rate of change at any point along the curve. From -2, this one is from -2 to any x. My slope is that equation. The part B says, use the results from part A, find the average rate of change of G from -2 to 1. So from -2 to 1. So it's -2, 1 minus 4. So the slope from -2 to 1, the slope is 6. So far, so good. Now, the third thing I'll ask you is the equation of the secant line. It's the same we did in algebra, finding the equation of a line. How do we find the equation of a line? What do you have to have? 2 points. So basically what we're looking for is this. The equation of the line. So the 2 points we have, it tells us from -2, G of -2, and at 1, G of 1 are 2 points. From x1, this is x1, this is x2. So G of -2 it's -2x squared plus 4x minus 3. -2 times 4 minus 8 minus 3 is -19. And when x is 1, -2 plus 4 minus 3. So -5 plus 4 is -1. So we have our 2 points. How do we find the equation of a line if we have 2 points? You have to find the slope first. Which is y2 minus y1, x2 minus x1. So here's x1, y1, x2, y2. -1 minus -19, 1 minus -2. -1 plus 19. That's plus 1 plus 2 is 3. So we have 18 over 3 is 6. So my slope is 6, which that's what we had earlier. Now what do we do? To find the equation of a line, we have a slope. We have to find the y-intercept. How do we do that? Choose either point and put it in for x and y. So I'm choosing 1, -1. This is x and this is y. I have to solve for b. So I have -1 equals 6 times 1. So -1 equals 6 plus b. Subtract 6. B is -7. So my equation M is 6 and B is -7. And there's my equation of the secant line. Brings back memories from algebra. It's just they put different names to it. Equations of a secant line. The secant line is just a line connecting 2 points on a graph. So there you have it. And if it asks you for rate of change, that's the slope of f of x2 minus f of x1 over x2 minus x1. It's just the same stuff we've been doing all along. It's just different names to it. Any questions? That does it for that section.
Wait, so rate of change is the same as like
Slope.
slope?
It is a slope, yeah. Because that's what we're going to use in calculus, because slope we use when we have linear equations, 2 points. Rate of change is how things in a secant in a function that curves, it's between 2 points. How are they changing? Okay, that's it for today. Did we finish early?